course, and in this video we'll be looking at redox reactions. What are redox reactions? The word redox comes from reduction and oxidation. So it's a short form for reduction and oxidation. And what is a redox reaction? In redox reaction, there's usually a transfer of electrons from one species or from one substance to another substance, and this usually leads to a change in the oxidation number of those species. So any reaction that involves a change in the oxidation number of a particular species, that reaction is known as a redox reaction. That is, a reduction or oxidation has occurred. So like I told you before, is an abbreviation for reduction oxidation. Now there are many definitions for oxidation and reduction, and like you see on the screen now, you can define oxidation in 5 different ways. Usually before now, you define oxidation in terms of oxygen alone. But later on, we discover that there are some reactions that don't involve oxygen that are still redox reaction. And that's why we came up with the other 4 definitions. We define oxidation in terms of oxygen, in terms of hydrogen, in terms of electrons transfer, in terms of oxidation number, and in terms of electronegative element. So, how do you define oxidation in terms of oxygen? So a reaction that involves addition of oxygen is oxidation, as you can see in this place. The one that involves removal of oxygen is reduction. A reaction that involves removal of hydrogen is oxidation. So you can see the opposite effect of hydrogen and oxygen now. Then the one that involves the addition of hydrogen is reduction. So when hydrogen is added to a substance, that is reduction. When it's removed from a substance, that's oxidation. When oxygen is added to a substance, that's oxidation. Now, the most widely or the most popular definition of oxidation and reduction is in terms of electrons, where you shorten it as oil rig. Now, in this oil rig, oxidation refers to loss of electron. The oil means that oxidation is loss. The rig means reduction is gain. So, oxidation is loss of electron, while reduction is gain of electron. You also define oxidation in terms of oxidation number. Whenever there's an increase in oxidation number of a species, that species is oxidized, and whenever there is a decrease in the oxidation number, that species is reduced. Then finally, you can also define oxidation and reduction in terms of electronegative element. So addition of electronegative elements is oxidation, whereas removal is reduction. So we'll take these definitions one by one and look at examples under them. The first is oxidation in terms of oxygen. So I've told you before that whenever there's an addition of oxygen, we call it oxidation, and removal is reduction. Now, the species that donates the oxygen is the oxidizing agent. The species that donates oxygen is the oxidizing agent, whereas the species that accepts the oxygen, you call it the oxygen acceptor, that is the reducing agent. An example is what we have here. You will see magnesium reacting with oxygen to give us magnesium oxide. So this reaction is simply addition of oxygen to magnesium. And take note, every combustion reaction is oxidation reaction. And look at this second reaction, where carbon is reacting with zinc oxide. You are going to see that carbon has no oxygen in this place at the reactant side, but when e get to the product side, it has 2 oxygen. That means carbon has been oxidized. And if you look at zinc oxide here, if you look at zinc oxide in this place, zinc has oxygen in this place, but when it formed product, it has lost the oxygen. That means zinc has been reduced. So in this place now, carbon is the oxidized species, zinc oxide is the reduced species. So this reaction is actually a redox reaction. So let's look at in terms of hydrogen. A species that accepts hydrogen is the oxidizing agent. That is, the hydrogen acceptor is the oxidizing agent. Please take note of all these details. Why the hydrogen donor is the reducing agent? Because when you accept hydrogen, you are actually reduced. So the person that donates the hydrogen to you is the one that reduces you. So that person is a reducing agent. But you that you accept the hydrogen, you are the oxidizing agent, because you allow the person to lose hydrogen, because loss of hydrogen is oxidation. And we have example in this place where sulfur in this place has hydrogen, but when it entered the product side, sulfur lost the hydrogen. So sulfur lost the hydrogen and become only sulfur. That means H2S has been oxidized because there's a removal of hydrogen from it. Also in this place, H2S reacts with chlorine, and you will see that the H2S became sulfur. That's another indication of oxidation. Then here, that's oxidation of H2S, and chlorine is reduced to HCl. So you can see that chlorine has been reduced because there's an addition of hydrogen to it. Cl has no hydrogen before, but coming to product side, it gained 1 hydrogen. We call that a reduction of chlorine, but also an oxidation of hydrogen sulfide. Now look at this place. C2H4 reacted with hydrogen to give us C2H6. So this reaction is actually a reduction kind of reaction that involves addition of hydrogen to a substance. So that is reduction. So that's how you define redox in terms of hydrogen. Now take note of this, that in any redox reaction, a species that is oxidized will become the reducing agent, while a species that is reduced will be the oxidizing agent. So when you are reduced, that means you have allowed somebody else to be oxidized. So you are an oxidizing agent. So don't forget that an oxidized species is a reducing agent, and a reduced species is an oxidizing agent. How do you define redox reaction in terms of electronegative elements? Addition of electronegative elements is oxidation, and removal of electronegative elements is reduction. I also define it in terms of electropositive elements. The opposite of electronegative is electropositive. So if oxidation is addition of electronegative, then it will be a removal of electropositive element, and vice versa. So we can see an example in this place where sodium is reacting with chlorine. Now chlorine is an electronegative element, right? So on addition to sodium, give us sodium chloride. That means sodium has been oxidized because we have added to it an electronegative element, which is chlorine. And you can see in this second reaction also where calcium is reacting with HCl. Now calcium ended up displacing hydrogen and becoming calcium chloride. Now in this place, calcium has been oxidized because there's an addition of chlorine to it. and chlorine is an electronegative element. So calcium has been oxidized to calcium chloride, whereas HCl has been reduced to ordinary hydrogen because we have removed chlorine from HCl. So that's a removal of electronegative element, so to give us hydrogen. So now in this place where calcium has been oxidized, that means calcium is the oxidized species. Calcium is the oxidized species, and HCl has been reduced to hydrogen. So HCl is the reduced species. HCl is the reduced species. Is a reduced species. So this is a reduced species. Now remember that an oxidized species will be a reducing agent. So calcium that has been oxidized now automatically becomes the reducing agent. The reducing agent. Whereas HCl that has been reduced will become the oxidizing agent. Oxidizing agent. So take note of that. Very, very important. Now, in terms of electron, like I told you before, that you define oxidation most popularly in terms of electron transfer. Oxidation is loss, that's oil. Reduction is gain, that's rig. So that's why we come about oil rig of electron. In terms of electron, oxidation is loss of electron, while reduction is gain of electron. So in this term, the electron acceptor is the oxidizing agent. So if you have to define oxidizing agent in terms of electron transfer, you say that oxidizing agent is an electron acceptor, whereby reducing agent is an electron donor. So let's look at this example. In the reaction between sodium and chlorine to give us sodium chloride, you are going to observe that sodium, a metal, loses one electron to become sodium plus. When you lose electron, that's oxidation. So sodium has been oxidized to sodium plus. So this is oxidation. That's oxidation. Whereas chlorine, that is a neutral element here, accepted supposed to be 2Cl now, not Cl2. So 2Cl accepted 2 electrons. Cl2 accepted 2 electrons to become Cl minus. So when you become a negative ion, you know what that means. You accept electron. You can only become a negative ion by accepting electron, and become a positive ion from a neutral atom now by losing electron. So Na lost electron and became Na plus. That's oxidation. Chlorine gained 2 electrons and became Cl minus. That's reduction. So now the electron acceptor is the chlorine. That is the oxidizing agent. Electron donor, that is the electron loser, is sodium. That's the reducing agent. So finally, in terms of oxidation number, you define oxidation as an increase in oxidation number of a substance in the positive direction. That is, +1 to +2 is oxidation, from +2 to +3 is oxidation, from 0 to +1 is oxidation, from -1 to 0 is oxidation. So when there's an increase in oxidation number of a species in the positive direction, you call that oxidation. But when there's a reduction or decrease in the oxidation number of a substance, you call that reduction. That is, maybe from 0 to -1, that's reduction. Or from +4 to +3, that's reduction. From +3 to +2, that is reduction. So as you can see in this place, This reaction is FeCl2 plus chlorine give us FeCl3. If you calculate the oxidation number of ion in this FeCl2, you know that it is plus 2, because if you have FeCl2, that gives you Fe plus minus 1 times 2 equals 0. So that gives you Fe minus 2 equals 0. So that gives you Fe is plus 3. So the Fe in this FeCl2 is actually plus 3. It's actually plus 2 rather, not plus 3. It's plus 2. It's plus 2. Now, the chlorine here is in the free state, so it's 0. Now, after the reaction, the compound became FeCl3. So the ion here is plus 3. That means ion changed from plus 2 to plus 3. That's oxidation of Fe, because there's an increase in oxidation number. Chlorine moves from 0 to minus 1. Now minus 1 is smaller than 0. So that means chlorine has been reduced from 0 to minus 1. So FeCl2 now was oxidized because the ion inside it changed from plus 2 to plus 3. So our FeCl2 is the oxidized species. Oxidized species. Whereas whereas the chlorine here change from 0 to minus 1 makes it the reduced species. The reduced species. So if FeCl2 is the oxidized species, that means that automatically it is the reducing agent. Is a reducing agent. And if chlorine is the reduced species, that means chlorine is the oxidizing agent. Another example is in this place where zinc, neutral atom of zinc, is reacting with copper 2 sulfate. Now, zinc here will be 0 because it's a neutral atom, and copper here is plus 2. How do I know that it's plus 2? When you have CuSO4. Now we know that Cu, we want to find the oxidation number of Cu. That will give us Cu plus minus 2. Minus 2 because SO4 is 2 minus. If you remember your radical table, the full sign of symbol of SO4 as a radical is 2 minus. That means the whole of SO4 is minus 2. So that's why I got Cu plus minus 2 equals to 0. So then Cu will now become what? Plus 2. So the Cu in CuSO4 is plus 2. Now if you now come to the product side, the zinc has turned to zinc SO4, and the CuSO4 has been reduced to ordinary Cu. How do I know this? Because zinc is in the plus 0 state at the reactant side. Now it's increased to plus 2. If you do what I did for CuSO4, for zinc SO4 too, you're going to discover that the zinc inside is actually plus 2. Because that will be Zn plus minus 2 equals to 0. So Zn will be plus 2. So zinc actually oxidizes from 0 to plus 2. While copper in CuSO4 reduces from plus 2 to 0. So that means zinc has been oxidized. That makes zinc the reducing agent. Then copper in CuSO4 has been reduced. So making that all of copper 2 sulfate has been reduced, so to ordinary copper. So that means that CuSO4 has been reduced. So it's a reduced species. So it's an oxidizing agent. So don't forget that your oxidized species is always the reducing agent, and your reduced species is the oxidizing agent. Now, before we go, and before I give you an assignment, you can be asked why we say that oxidation and reduction reaction are complementary processes. The reason is that, or the meaning is that, why is it that oxidation and reduction must occur simultaneously? Now, the reason is this: for a substance to lose electron, or for it to donate electron, which is oxidation now, there must be another substance available to accept that electron. That's reduction. So if there is no substance available to accept electron, you are not permitted to lose an electron. So that's why we say that for every electron donor, there must be an electron acceptor, so that for every oxidation there will be a corresponding reduction. So that's why you say that oxidation and reduction are actually complementary processes. Don't forget, in summary, we define oxidation and reduction in 5 different ways. In terms of oxygen, that's addition of oxygen. In terms of hydrogen, that's removal of hydrogen. In terms of electron, that's loss of electron. In terms of oxidation number, that's the increase in oxidation number. And in terms of electronegative element, that's addition of electronegative elements. So I'll be giving you some exercises here. You have to identify the oxidized species, the oxidizing agent, the reduced species, and the reducing agent in the following equations. So I'm having first 3 in this page. Then you can pause the video to do the assignments there, and then the last ones are in this place. So identify the oxidized species, the oxidizing agent, the reduced species, and the reducing agent in the following equation. Thank you.